Assalamualaikum. I am from group 10, consisting of myself, Ahmad Afif Razi, and Kuhanres, anak lelaki Kandar Sami. For our objective, first to study, learn and understand about the concept of electro-pneumatic and safety procedure for handling the system. Second, to design, simulate, troubleshoot and modify the electro-pneumatic control circuit that consists of 3-cylinder, sensor, timer and counter based on problem statement by using fluid sim software and the indirect actuation method. Then to analyze the operation of the control circuit. To build the displacement state diagram based on the operation of cylinder. Then to identify the problem and propose a solution based on the circuit failure. For displacement state diagram, the displacement state diagram for the original circuit for the cylinder A from 0 to 1 will extend until 2 seconds. From 2 seconds until 3 will be retract. For cylinder B, from 1 second will extend until 2, and then 2 seconds until 3 will retract. For cylinder C, from 2 seconds until 3 seconds will extend, and 3 seconds to 4 seconds will retract. For the displacement state diagram for the modification circuit for the cylinder A, from 0 to 1 will extend until the end of the program. For the cylinder B, from 4 seconds until 5 will extend, 5 seconds to 7, then from 7 to 8 will retract and then will extend back. Now for the cylinder C, same with cylinder B.
Hello, hi doctor. My name is Kuhan Raj, unlike Kandasamy, and my matrix number is CN210335. So I'm from group 10 for the Electro-Pneumatic group project. So here I'll explain about the problem statement, the operation system, the components we used and the purposes, so everything. So now jumping to the problem statement slide. So this is our problem. So let me read it first, later I'll explain. So in a canned sardines company, there is a problem which the number of canned sardines in a container is not exactly as the order of the sorting thing. In the quantity of canned sardines in a container will be more or less, and some are different labeled. So we have created a solution. So that's the problem, where usually in a can based companies there will be at the output there they'll calculate how many containers, how many cans of sardines or drinks, beverages are in a container for packaging. So in this problem, those number of can is not same. One will be more or less. It is not accurate as they ordered by the company. So we have created problem. So this is fully automatic. There will be no humans, only in the input and output. Later I will explain to there will be 3 sections in the process, in the solution process. So there will be only 2 people in 2 sections. So less human in this process. Okay, now I will explain to you about the 3 cylinders or 3 sections, and where the cylinders will be placed in sections. So starting from the clamp section. So cylinder A, this is because this cylinder A will hold a basket or a container. It's like a clamp. So when this cylinder B and C, when they doing their task, the basket or the container will not move. Okay, so in cylinder B or the eject section, so that's where the one people, I mean like a human, they will keep canned sardines or anything item in front of the cylinder in that section. So they have to make sure those cans are the one need to go into the packaging. So they have to check it. So they will place it. So what this cylinder B will do is will push it or give it to the cylinder C. Okay, so cylinder C or out section. So this is the last section here. This cylinder C will push those the canned sardines or any items from the cylinder B to the basket, which is clamped by the cylinder A. Okay, after this process, then only another human or another people who is working there will take the container back. So until then, there will be no any human doing from A to Z. They'll be just helping and make sure those containers, those canned one are the one need to go to the basket. In this slide, I will explain to you about two different circuit. First of all, the sequence of movement of piston rod cylinder of two circuits. One is the original, another one is the modified. So in this project, we have done a first circuit, and that circuit has things to be developed so that there will be no any errors and the process will be more smooth and easy. Okay, so on the original circuit, so step 1, cylinder A will extend. Step 2, B will extend. Step 3, C will extend. Step 4, A will retract first, and then step 5, then only B and C will retract. Okay, so I modified, so I have added some timer. So in step 1, A will extend. As once the push button is pushed, A will extend. Step 2, after 5 seconds only, the B will extend. So there will be a time to the people, like I said, to check whether the can they are holding, they're keeping now, is the one going to the container. So after that, they'll keep in front at the eject section. Okay, so they have some time, like 5 seconds, like that. I think is enough. So those times can be modified later, so according to the people. So this B will extend, and then step 3, after B extend fully, so I have keep a sensor there. So once this rod cylinder B is fully extend, then only the C will extend. So that's where the out section, where you will push the cylinder, the can to the container, which is clamped by the cylinder A. Okay, so after 2 seconds, so once the B and C is extended, okay, after 2 seconds only it will retract back together. So cylinder A will not retract until step 5 is completed, which is A retracts after step 2 till 4 are repeated for 5 cycles. So I have also applied a counter. This is because how many canned sardines or any item need to be placed in a container or a basket. So those counter can be changed, modified. So for example, in a container they need 10 canned sardines, which means they can put it the counter as 10. So now for example, I just put 5 cycles, which means 5 canned sardines only will be putting inside the first container. Okay, so once the step 2 and till 4 is completed, then only the A will retract back to the original position. So that's what the cycle or the process is complete. So once complete, the worker can collect the basket and start give to the sorting team for the package. Okay, in this slide I've placed a component list used in the original circuit. So what are the components used in electrical circuit and also pneumatic circuit? So first of all, electrical circuit, I've used 1 push button, 4 coil relay, 8 contact relay, 1 limit switch, 5 solenoid valve, 2 magno-resistivity sensor, 1 counter, and 1 counter contact relay counter. Okay, so at the pneumatic circuit, 1 air compressor, 1 air service unit, 3 5 two-way double directional control valve, and 3 double acting cylinder. In this slide I have shown a component list in modified circuit. So first of all, In electrical circuit, I have used 2 push button, 4 coil relay, 9 contact relay, 1 limit switch, 5 solenoid valve, 2 magno-resistivity sensor, 1 counter, 1 contact relay counter, 2 timer relay, and 2 contact relay timer. Okay, moving to the pneumatic circuit, 1 air compressor, 1 air service unit, 3 5-way double directional control valve, and 3 double acting cylinder. In this slide, I have shown the actual circuit diagram of the first circuit I have done, which is the original one before any modification or what. So here later I'll explain more about this original and modified circuit and when I'm doing the simulation. So first of all, there will be one push button, and then together with the coil relay and all the magneto-resistivity sensor, solenoid valve, counter, contact relay, plus what are the C1, which is the counter contact relay. So here's the one. Later I'll explain more. So how it works. So there were 3 cylinders. Like I said, when you push the push button, it will move after that accordingly. This is the modified circuit diagram. So there will be some add-ons and some modification development, which is there will be another one, reset push button, so that to reset everything, all this whole circuit. They got timer, 2 timers, and then the same as the counter, 2 magno-resistivity sensor, 1 push button, the first one, and then the contact relay, coil relay, solenoid valve, and some the timer, contact relay, and also limit switch. So later I'll explain more. Before going to the simulation, let me compare both circuits. One is the original circuit, another one is the modification circuit. Okay, so in the first one, the push button is to be keep on pushing. When we want to activate the circuit, you have to keep on pushing or press shift in the laptop. So it's because it will delay the process, so you need to keep on pushing so that the circuit will keep acting. So in modification, I have added latching, so that the push button just need to be pressed once. So once you pressed, automatically the circuit will be active. Okay, so moving to the next one, cylinder A extends right after push button is pressed. So both cylinder B and C will extend and retract together. Cylinder A will retract after the cycle which has been fixed is achieved, okay, by the counter. In modification circuit, cylinder A extends right after push button is pressed. After 5 seconds, cylinder B will extend. Once cylinder B extends fully, then only cylinder C will extend, where the limit sensor will play the role there. So after 2 seconds, so after the cycle, the process on, after 2 seconds, cylinder B will retract together with the cylinder C, but still there will be some delaying time. So first cylinder B will go first. After 1 second, if not mistaken, then only cylinder C will retract. So counter will make sure 5 cycles are completed, as I said, by cylinder B and C. At last, cylinder A will retract. So this is the end of the process. So the next one, no reset button is applied in the original circuit, but there is a reset button is applied in the modification circuit. Okay, no latching in original circuit, but there is latching in modification circuit. No timer in the original circuit, but I have applied 2 timer in the modification circuit. So this is the comparison of both circuits. Okay, doctor, so this is the simulation of the original circuit without the modification. So there will be 3 cylinders. Okay, so now I just, okay, it is in on mode. So once I press this push button, I just cannot leave it, so it will not active. So what I do is I just need to keep on pressing. So this thing will give movement. So the cylinder A will first extend. After that, the cylinder B and C will extend as proposed. So once this push button is pressed, this KF1 coil relay will energized, and then this contact coil relay of KF1 will be opened, sorry, yeah, closed, so that it will give power to the magno-resistivity sensor negative BG1. So together with that sensor detects, and it will energize this coil relay which is negative KF2. So as I said, this negative KF2 will be energized and it will open, so like closed. Okay, so once it is closed, it will give power supply to the solenoid valve negative MB1. So what this will do is, it will extend the cylinder B. Okay, so extend the cylinder B, so air will go here and then extend. So for this negative MB3 or the cylinder A, I have kept on here. So once we just press it and this is thing energized, this coil relay energized, together with this and this will work together. So this thing will push the cylinder extend, will extend the cylinder. Okay, well yeah, okay. After that, this automatically, once this thing this coil relay is active, sorry, energized, automatically counter relay will start to work, sorry, counter one will start to work. Okay, so here this magno-resistivity negative BG2 will sense the here. So once this cylinder is extended, automatically it will energize this coil relay. After that, this contact will be closed. Together, this negative MB2, which is here, will push or retract back the cylinder B. Okay, so this have done, and here together same, and this thing will also retract, so extend. Okay, will extend the cylinder for a while because it's very fast acting cylinder, so it will extend, push the sardine can, and then back to the position. So what will make this thing retract is this. Okay, this limit switch 1 will make sure this cylinder, this rod cylinder, piston rod, once it hit this limit switch or the sensor, then only the automatic will cut off here. Okay, will open. Okay, so when open, no power supply is supplied to the solenoid valve, and automatically it will be pushed and or retract back. Okay, so in this problem also, we have found one problem, so that's why we have modified this contact. This counter has their own contact relay. Okay, so but well, okay, sorry. Once this cycle is done, he will energize this coil relay. Okay, so once this coil relay is energized, then it will cut off whole system, where we have given here one contact relay. So to indicate there's a completion in this circuit, but it does not work and it just keep on moving. So I have done some modification in the modification circuit, which are present now. Okay, doctor, this is the modified circuit of the project group 10. So now the power is on, so now I just have to press this push button SF, negative SF1 once, so automatically the cylinder A will extend. After that, together with the cylinder B and C will extend according to the timer. So I have added in the timer here. So right after 5 seconds only, here this cylinder B will extend. Okay, so after that, automatically it will make the cylinder C to extend, because there is a sensor here. So this negative BG2 will say that once this rod cylinder has reached this sensor, automatically this will be ignite. It's because here is negative MB4, the solenoid valve here. So this is the contact relay here. So the coil relay is here. So this sensor will energize this contact relay, coil relay, where it will give information to this contact relay to make this cylinder to extend. Okay, so I have also make some modification which is placing the latching, also this timer contact relay. So here there's another one, timer contact relay for this timer, and this timer has contact relay here. Okay, so yeah, solid number as usual, and then I have also added in no, this is as usual limit switch 1. So like I said, this will will open, so it will not give power supply to this solenoid valve to make this thing to retract back. So okay, and then like I said, after 5 cycles it will automatically shut down. So here this counter can be modified according to the order of the cans. Okay, so and also I have some stop button, or yeah, this is stop button. So for example, now the circuit is running and I want to, there's some problem and I want to stop the circuit immediately, or the process. I just need to press this one and automatically the whole process will be shut down. Okay, and also after this counter is achieved, like I said, this counter is one, also this whole circuit will be turned off. So once it reached, it will be turned off. So all the cylinder will be back to their own old position, which is retract position. So these are the actual project which we get. Okay, once again I just go through it. So once this push button is pressed, this negative KF1 coil relay will be energized, and this negative contact relay for KF1, these two will be closed, and this timer will be activated. So right after 5 seconds only, this cylinder B will extend. After this thing extend, which is this cylinder B extends, this sensor BG negative BG2 will detect the appearance, the presence of the rod cylinder. So then only it will. So like I said, once this rod cylinder once this negative BG2 sensor detects the presence of this rod sensor, automatically it will make sure this cylinder C to extend. So because of this negative MB4 solenoid valve is here, and this contact relay will activate. Okay, so this counter will be activated by this contact relay, which is energized. This coil relay will be energized by the sensor, which will make active of this contact relay. So same together with this timer. This is the contact relay and this is the coil relay of both of them, and this will be activated by this sensor negative BG2. Okay, so here also the contact relay for the timer. So right after 2 seconds this will be cut off. Okay, right after 2 seconds this will be on, so that power supply will make active this solenoid valve, and this negative MB2 will be pushed or retract. So yeah, this is the one, and here this is the C1, which is the contact relay for this counter. So after the cycle completed, this thing will be closed. So once it is closed, power supply will go here and energize this coil relay KF4. So this will active this contact relay will cut off, which will cut off the whole circuit. So that's all from me. Okay, hi doctor. Okay, so as a conclusion of this project, I hope that the circuit I have created together with the original circuit and also the modification circuit has fulfilled the requirement of the problem statement, like I said. So mainly it's about a sardine can company. Okay, so they're having a problem which those containers has not enough the order of canned sardines. So this solution will make sure that each container, before packaging, each container has the accurate number of canned sardines which as they have ordered. Okay, so there will be no any more or less or different type of can. So the workers must make sure those can they're keeping in the process in the cylinder B is correct, so that there will be no any errors occur. So the counter plays role as the how many cans or how many items need to be in the container. So if it's 5 or it's if 10 means we can just modify it and put it as 10. So overall, this electropneumatic subject or this electropneumatic system is very well known, and for me it should be easy if we know from A to Z. So how to use the software, if we need to learn about the electrical circuit, the pneumatic circuit, the components, the usage of the components such as 3-way solenoid valve, 5-way solenoid valve. So the use of the contact relay, use of coil relay, the use of counter, timer, so where we need to keep the latching so that the circuit will be active. So when we know everything about this electropneumatic, it'll be easy and we can do anything. We can in a company, if there's a problem, so we can use this software or this system to troubleshoot and also to create a solution. So I hope that we have tried our best, and also I hope this project has fulfilled the requirements. So that's all from me. Thank you.